So, as I said, in number 6, we're going to start there. So, we said that that was a rate of change, it was constant, and therefore was a linear relationship. Let's look at number 7. It says the same thing. Determine whether the relationship between the two quantities shown in the table is linear. If so, find the constant rate of change and interpret its meaning. So, we're going to do the same exact thing from 11 to 12, that is a plus 1. From 12 to 13, plus 1. 13 to 14 plus 1, and then 14 to 17, that is a plus 3. So from here, from 5.5 to 6, that is a half, 0. 0.5. From 6 to 6.5, that's a 0. 0.5 or a half. And then 6.5 to 7, that is a half or 0. 0.5. And then 7 to 8.5 is 1.5, so 1.5. So we're going to do y divided by x. Here's our y, and number of people are x. So remember, minutes, number of minutes per person is what we're doing. So that's going to give us 0.5 divided by 1 is 0.5. 0.5 divided by 1 is 0.5. 0.5 divided by 1 is 0.5. And then we got to do the last one, which is 1.5 divided by 3, which would also give us a 0.5. So what that is saying is 0.5 minutes per person. But what is a half of a minute? Well, most people say that's 30 seconds. So about 30 seconds per person. 30 seconds per person. Okay? So now we've already interpreted ours. We can see that the rate of change is constant. That means they're all the same. So I'm going to write the rate of change is constant. Therefore, it is linear relationship. Okay. Number 8. It says the graph to determine whether use the graph to determine whether the relationship between the two quantities in the table are linear. If so, find the constant rate of change and interpret its meaning. If not, explain your reasoning. So here, when we look at this graph, we can clearly see that it is a straight line. So all my students know all straight lines are linear. So we're going to write it is linear, or it is a linear relationship. Sorry, because it is a straight line. Therefore, we know that the rate of change is constant. Now, we need to pick 2 points so we can find the constant rate of change. Pick 2. That's what I have kids write. I'm going to pick, you can pick any 2 of the 3. I'm going to pick 4, 36, and 16, and 144. So I'm going to say 144 minus 36 because it's the change in y divided by the change in x. That little triangle means change. Change. So 16 minus 4, and that's going to give you 108 and 12. 108 divided by 12 equals 9. But what does 9 mean? It means, remember, we're doing the change in y verse. So 9 books per hour. 9 books per hour, or each hour, or every hour to that effect. Okay. So we're going to try to do 9 and 10 on this video, and then we're going to do the rest on another video. We're probably just going to get to 9 because it's a long process. So we still find if it's linear, the rate of change, and its meaning. But this time we're talking about proportional reasoning. So for that reason, our proportional relationship, for that reason, we got to find our ratios. We learned about ratios in 7th grade, where you compare one thing to another, like boys to girls, or wait time to number of people in line this time. So we're gonna get those proportional, and we're still gonna do our change. So 5 to 10, 10 to 5, 50, and 15 to 20. Those are all plus 5 changes. And here, all these are plus 15 changes. So we're still doing y divided by x. So number of minutes divided by the number of people in line. So 15 by 5 gives you 3. 15 divided by 5 is 3. 15 divided by 5 is 3. Now, if I was on my own sheet of paper, I'd probably do this a little different. I would say 3 minutes per person each time. But I don't really have that much room, and that's why I'm trying to say, and I apologize for that. 3 minutes per person. So people waiting in this line about 3 minutes for each person. So we know from that that the rate of change is constant. So if it is constant, that means it is linear. It is a linear relationship. Okay. So next we need to do our ratios, because if the ratios are not constant, then it's not proportional because they both have to be constant. So the ratios are comparing wait time to number of people in line. So 15 divided by 5 is 3. 30 divided by 10 is 3. 45 divided by 15 is 3. And then 60 divided by 20 is 3. So the ratios are constant. The ratios are constant. So I'm going to write that so they'll know. Ratios are constant. And since the ratios are constant and the rate of change is constant, it is a proportional relationship. So we're basically going to do the same thing with number 10, but it is a graph. So we automatically know it is a linear relationship because it is a straight line. And we know that the rate of change is constant since it is a straight line, because we know what number would possibly come next. So we can write all of that. It is linear because it is a linear relationship because it is a straight line. So again, I'm gonna do number 10 on another video because we're running out of time, okay? I'm gonna do number 10 on another video. I'm gonna stop here. We're gonna come back on